Hello everyone, welcome to IGBits. A warm welcome to all subscribers, listeners, watchers who are presented in today's session. We shall continue our learning a concept of partial fractions rule number 2. Request to all viewers and listeners, if you have not subscribed the channel, please subscribe our YouTube channel. We have started uploading all learning videos on timely basis. Okay, a great help and great helping hand to extend who are actually in need would be a great the support to the system, right? So we are trying to put our efforts to build the knowledge base, and then I want you all help us to share the knowledge sharing sessions to the your friend circles, extend your support and be a helping hand to build a great knowledge competency teams. Thank you all for your wonderful support so far, whatever you did it, but I would like and wish it to be continue further. Thank you all. All right. Before getting into the rule number 2 of a partial fraction, we will see few concepts. Okay. Let's say, for instance, I have 3x minus 1. So how many values that you can get it from for x value? How do you say 3x minus 1 equal to 0 and then x equal to 1 by 3? Is it one value? So x to the power of 1, the degree of x, this polynomial is 1, and hence this equation should contain one value, which is also known as a root. Right? Sometimes we can call it as quadratic equation or a polynomial equation. When you are trying to solve, we can understand based on the degree, we will be figure that out, like how many values of x that we can get it. Let's say, for instance, x square minus 1. Tell me how many roots that I can get it. How many x's I have? The degree of x is equal to 2. Is it? Degree of x equal to, right? And hence we will get 2 roots. Let's see how. X square minus 1 can be written as x plus 1 into x minus 1. Isn't it? Equal to 0. Then x plus 1 equal to 0. X minus 1 equal to 0. So x equal to minus 1. Whereas x is equal to plus 1. So x values minus 1 plus 1. Correct? Because of this degree, you will be able to get the answer. Similarly, if you look at 2x plus 1 divided by, which you can say x square minus 1. How do you write this one? A by x minus 1 plus b by x minus 2, because x minus 1 and x minus 2, x plus 1 are factors for x square minus 1, right? These two are the factors, isn't it? So if you see, this is one root, this is another root for this x square. You will be able to understand this logic, isn't it? If I say 2x plus 1 divided by x minus 1 whole square, how do you write this one? Question, how do you write? Let's say a by x minus 1 plus b by x plus 1 x minus 1. Can you write something like this? We never know, right? Because how this is going to solve the problem. If you say this, do you think like this is correct representation? So I'm sure this is not the right representation, correct? Because the LCM what we can get is x minus 1, then and the numerator whatever it comes, right? So what exactly we need to get it? Power, because denominator should not be different than what was given, isn't it? So let me reiterate again. 2x plus 1 by x minus 1 whole square. Probably I see a by x minus 1 plus b by x minus 1 whole square. Now you see what would be the LCM for this? X minus 1 whole square, and then a times x minus 1, because x minus 1 and x minus 1 whole square. So if we can multiply numerator and denominator by x minus 1, what you can get is a into x minus 1, then the denominators would be same, right? Plus b. This is how you can decompose the given equation. Any doubt? So based out of the power, we should be able to understand how we can express into partial fractions, and then how many roots that we can expect after solving this given fraction. I hope you're clear, because most of the the problems under partial fraction rule number 2 will be using these concepts. So let's look at rule number 2 of a partial fraction. For a given proper fraction f of x by g of x, where g of x is in the form of ax plus b whole power n, we have a condition like a is not equal to 0 and then n would be a positive integer of g of x. In that case, there will be a partial fraction in the form of a1 by ax plus b, a2 by ax plus b square, so on, an nth term, an by ax plus b whole power n, where a1, a2, a3, a4 till an are the non-zero real numbers, are the constants, non-zero real numbers. This is how we have to understand. The rule number 1 is non-repeatable, but rule number 2 is a repeatable case. If given proper fraction, if there would be a repeatable g of x in the power form, right? In that case, the way that you have gonna represent partial fractions are in this form: a1 by ax plus b, a2 by ax plus b whole square, and so on. Let me give you simple, the example. Let's say the case is, are you ready? Well, x square plus 13x plus 15 divided by x plus 3 whole power 3. How do you represent this one? You have to represent like a1 by x plus 3, that's the first term, plus second constant a2 divided by, you have to raise the power, x plus 3 whole square, then a3 term, a3 by x plus 3 whole cube. So we have a degree of 3 and then you should end with a 3. That's what meaning of your n, right? N means n terms. Okay, this is ax plus b whole square till ax plus b whole power n. Got it? So this is how I think we have to represent the partial fractions. Okay, based on the rule number 2. Then Rest of the solution is common as a rule number 1. Alright, let's try this one. Resolve given fraction into partial fraction. By looking at this one, you see there is a repeated fraction, right? The repeated factor of a fraction. This is definitely rule number 2. So as per the rule number 2, if you wanted to express given fraction like x square plus 5x plus 7 divided by x minus 3 whole cube. How do you represent this one? a1 by x minus 3 plus a2 by x minus 3 whole square plus a3 divided by x minus 3 whole cube, right? Because of 3, so we are end with 3. I hope you are clear at this point. Now you put in LCM and then equate the only numerators from both LHS and then RHS. So x square plus 5x plus 7 equal to, if you can LCM, what happens? X minus 3 whole cube, that's what you get it, right? And hence a1 x minus 3 whole square, because multiplied by x minus 3 whole square numerator and denominator, then denominator would be x minus 3 whole cube. So a1 x minus 3 whole square plus a2 into x minus 3 and then a3 you don't require. This is how you will get it. Clear? So now you have to use elimination method by substituting x values. Let's put x equal to 3. What happens? This becomes 3 squared plus 5 into 3 plus 7 equal to, this becomes 0 because 3 minus 3. So a1 of 0 plus a2 of 0, right, plus a3. So this one is 9 plus 15 plus 7, right? So 9 plus 15, how much? 24. 24 plus 7, how much? 31. Okay, so 31. So 31 equal to your a3. This is done. Now how do you fix the next problem? This area, compare the coefficients on the both sides. Second option. Let's compare coefficients, right, from the both sides. In both LHS and RHS. Let's say for instance x squared, right? So x square case, if you see, coefficient of x square is 1. This is 1. Here a1, right? Because this is x square, is only one x square you will see. So a1 now become 1. Clear? So how do you solve the next term? Let me change my color to white maybe. Alright. Okay. Any guess how to solve the next one? What we can compare? Maybe you can compare only x terms, right? If you compare, okay, only x coefficients, right? X coefficients. Here what happened? The term is 5x, so it's a 5 equal to, in this case, x square minus 6x, right? So a1 minus a1 6 is what you get it. Here a2, correct now? Then we know a1 how much? 1. So 5 equal to minus 1 into 6 plus a2. So how much a2 now? 5. This is like minus 6. If you can move to the left, minus becomes plus, so plus 6. So a2 is 11. So the total equation now, a1 means 1 by x minus 3 plus how much a2? 11 plus 11 by x minus 3 whole square. Then how much a3? a3 is 31. So 31 divided by x minus 3 whole cube. This is the partial fraction for a given proper fraction. I hope you are clear, right? This is simple one, and then this follows exactly the same rule like a rule number 1. Only difference is there is a power degree in the denominator. This means a repeatable factor. Because this is a repeatable factor, the rule number 2 is follows, which is how you have to represent. Based out of the power, you will have those many partial fractions to express the given fraction. Next problem, for a given fraction, we have to express partial fractions. Let's see, this is a combination of non-repeatable and repeatable factors, isn't it? In this case, we have to use concept both rule number 1 and rule number 2 together. Okay, how do you represent this one? 1 by x minus 2 and x minus 1 whole square. So a by x minus 2 for this one plus b by x minus 1, because this is x minus 1 whole square. So first you have power 1, right, plus c by x minus 1 whole square. Are you clear? This is a non-repeatable, so and hence one constant a divided by x minus 2, and then this is x minus 2 whole square, and hence I'm repeating twice. First b by x minus 1 plus c by, see constants, right? Either you can use a1, a2, a3 or a, b, c. These are unknowns, and then these are what you are going to find out, isn't it? So don't get confused. Now we put in LCM. LCM is like how much? X minus 2, x minus 1, x minus 1 whole square becomes x minus 2 and x minus 1, isn't it? So this value would become how? If let me erase this one. Okay, good. What I was trying to do here, I will try to put the one time the equation 1 divided by x minus 2 whole square and x minus 1, right, whole square equal to, what would be the LCM here? LCM would be x minus 2 into x minus 1 whole square, correct? No? So in order to make denominators are same, what I'm going to multiply here, both numerator and denominator, x minus 1 whole square. So a x minus 1 whole square, right? Because x minus 2 already there. Now in this case I have x minus 1, so what is not there, x minus 2 and x minus 1, one more x minus 1 is not there, so b into x minus 2 and x minus 1 is what you needed. Similarly for c, what is needed, x minus 2 only, correct? Now this you have to see. Now you can only compare numerators for both cases. So 1 equal to a into x minus 1 whole square plus b into x minus 2 and x minus 1 plus c into x minus 2. So how do you identify them? You properly understand, like, compare both sides and then try to get what would be your answer. Okay, let's try out. Little tricky here. You have x square terms, right? This is an x square term. We have this here also an x square term. If you look at here, x square term is missing. So 0 equal to a plus b, right? So a plus b equal 0, a equal to minus b. We'll see how to get this one. Next one, if you are trying to substitute x equal to 1, then this term is go, and then this term is also go, and then what is left over? 1 equal to c into 1 minus 2, which is nothing but minus 1, and hence c equal to minus 1. Good. So now let's compare only x terms, both sides. Compare x terms. So left hand side you don't have, so definitely a 0. Okay, right hand side, what is x term here? X square minus 2x plus 1, right? Minus 2x, so minus 2x means like minus 2a, x terms, right? What you get in this case, what is x term? Minus 2x minus 1x, right? Minus 3x, right? So plus b, what do you say, minus 3, right? Here c only, but c is already have minus 1, so 0 equal to minus 2a minus 3b minus 1. So if you apply minus a, 2a plus 3b equal to minus 1. Alright, so how do you solve this problem? Here is a is equal to minus b. Let's substitute this value here. 2 into minus b plus 3b equal to minus 1. Minus 2b plus b, so b equal to minus 1. If the b is equal to 1, what would be the a value? A equal to minus of minus 1, so 1. So now we have a, b, c. So if you can plug in into partial fraction, what would be our answer, right? A means 1, so answer 1 by x minus 2. What is the b value? B is equal to minus 1, so minus 1 divided by x minus 1. What about c? C is equal to minus 1, so minus 1 by x minus 1 whole square. This is our partial fraction. So what is a change over color for me? I will use a different color to give a box. This is your partial fraction. I hope this is clear. Very good actually. Yeah. Thank you. Thanks for watching. Please like, share, subscribe, click on bell icon and leave the comments. Thank you all. We reached the end of the session today. We will see few more concepts in next session. Until then, have a good day. Bye bye.